So chapter 10 is dealing with quadratic equations, and there's a variety of ways of working with those. You've already worked with quadratic equations back in, let's see, chapter 5, I think it was, back in basic algebra, because in that section there were things where we did, actually chapter 6 it was, because it was factoring. Remember factoring? We're going to pull factoring back as a method we can use, but there's a whole lot of other methods we can use with this as well. So let's take a look at some of these. And so in 10.1a, it's looking at factoring, trinomials, or quadratic equations, I guess I should say. And using the square root method. So we're going to do both of those things. So if we start out with, this is our equation, x squared plus 6x equals 16, well, it looks like a quadratic. Quadratics usually have something that is squared in them, and they have, in most cases, 3 terms, and they're usually are set equal to 0. So we need to set this equal to 0. So if I set it equal to 0, I have x squared plus 6x minus 16, because I'm going to minus 16 from both sides. That's what gets it over there. So it's set equal to 0, and being set equal to 0 is very important. So you want to make sure you get that 0 thing in there. So does this factor? So then I'm going to look at it and say, okay, can I factor it? What are factors of a negative 16 that give me 6? Well, because the 16 is negative, that means one of these is negative and one's positive. Remember back from factoring. 2 values that multiply to give me 16, negative 16, but add to give me 6 in the center is our usual rule. Negative, is it negative 8 or positive 8? Positive, yeah, negative 2 and a positive 8 equals 0. And so to solve my quadratic, all I simply do is set these equal to 0 and solve for x. So I'm going to add 2. And over here I'm going to minus 8. And I find out that x is equal to 2 or a negative 8. Now in Hawks, when you enter those, of course you put in negative 8 comma 2. You do not have to put them inside of anything. I think it just accepts them inside of parentheses, and you come up with what your answer happens to be. So that's with factoring. So I'm always going to look at stuff and see if I can factor it. But if I can't, then I got to go and use something else to work with it. Another one we ran across in factoring was when we had a number out in front, and we had to factor those. Those were those long, drawn-out ones because I couldn't end up factoring, or we used trial and error in some cases, or we used that method where we multiplied the first term times the last term, so we kind of review that a little bit. 2 times a negative 7 is a negative 14x squared. So I need things that multiply to give me a negative 14x squared, but add to give me what? What do we want to find? Negative 5x. Yep. So what would they be? Multiply here, add here. Negative 7x and a positive 2x. Negative 7x times 2x is negative 14x squared. Negative 7x and 2x is negative 5x. Then I take this piece that I just found and replace my middle. So 2x squared minus 7x plus 2x minus 7 equals 0. Use my grouping stuff that we did way back when too. Again, make sure you put that plus with the 2x in there because that helps you out. What can I pull out of the first piece? So I'm going to factor what I can out of here. So what comes out of there? An x, leaving me with 2x minus 7. And what can I pull out of the second one? Only a positive 1, right, because they don't have anything in common. But if you notice, they both match each other. So that's my goal, is when I remove something out of each of these 2 pieces from above, the end results of that binomial has to match each other, and they do. So 2x minus 7 equals x plus 1, all equals 0, and because I'm in a quadratic, I need to finish them and set each equal to 0. And when I set it equal to 0, what do I get? Now, this side, I'm going to add 7. Divide by 2, and I find x is 7/2. Over here, I subtract 1, and I find x is equal to a -1, and so that's my two answers that I have for that quadratic. Do I have to check them and make sure they work? If you go back and check them, you will automatically know whether you have the right answers or not, okay? But you don't have to plug them in like we did in that last section in Chapter 9, where you had to make sure that they were true answers. You basically know that they more than likely will be, okay? So the other thing that we have with these is you got the factoring, so I think you're okay. Are you okay with the factoring part? So again, always look at them, see if they can factor, but if they don't, then you gotta try something different. Once in a while, they will give you something like this, and when they give you that, we all know that because it's a difference of perfect squares, we get x minus 2 and x plus 2 equals 0, correct? When we factored it? Okay. Now our rule that is that square root method, can take this thing and turn it into another way of looking at stuff. And what that means is that if I have the square root method, if I add 4 to both sides, I get x squared equals 4. We all agree? X squared equals 4 because I can move it over. So what could x possibly be? Well, we've talked about that quite a while ago. What could this base be? It could be a -2, couldn't it? Or it could be a +2. So what ends up happening with my square root rule is it says take the square root of both sides and when I do that, I take the square root of x squared equals the square root of 4. But the thing that's going to come out of this is when I take the square root of x squared, I get x. But when I take the square root of 4, I'm going to end up with always putting in front of this a plus or a minus. So put a plus minus in front of the value because it could be a plus or it could be a minus when I work that one out. Now when you put this answer into Hawks, it's going to give you two boxes. One is for the +2, the other is for the -2. So you have to break it apart. In a lot of math classes and a lot of, if you're doing your stuff on with paper and pencil, a lot of times your teachers or instructors would let you leave it like this. But in Hawks, it wants you to break it apart and give you both answers, okay, instead of leaving it in the one response only of what you have. The ones that get kind of strange with this are when you have x squared minus 5 equals 0. Can I factor that? Well, when I look at it, I'm like, it's not perfect squares. So way back when we were in Chapter 6, we would say, not factorable, okay? But we're adding more things in your toolbox, so we are going to add 5 to both sides and get x squared equals 5. Use my square root rule that says if I take the square root of x squared, I get x. Square root of 5 gives me a plus or minus the square root of 5. Again, don't forget to put that plus and minus in there. So my true answer to this one is it's the square root of 5 and a negative square root of 5. So I can start doing some more stuff with some of these and come up with answers that we end up with double stuff on. That makes sense? Hopefully. Okay. If it has a number in front of your square root, I can't just take the square root of each side because 5 is not a perfect square. So you need to get the square value by itself. So to do this on this one, 5x squared equals 75, all I do is divide by 5, and I find x squared is equal to 5 goes into 75, 15. Whoops. And take the square root of each side. So x is equal to plus or minus the square root of 15. But can I break that down? Can I break the square root of 15 down at all? What do you think? Can't do it, right? Because 15 is made up of 3 times 5, and 3 and 5 are not any perfect squares of any sort. So that's kind of where I need to leave that one at, with that one. If they give you something inside of or connected to that value, such as x plus 2 squared is equal to 13. X plus 2 is equal to 13. This squared piece is by itself. So if it's by itself, that's great. 13's all the way over there. So now if I take the square root of x plus 2 squared equals the square root of 13, this side leaves me with x plus 2. This side leaves me with a plus or minus the square root of 13. But what do I notice? Notice anything about that? X isn't by itself, right? So I'm going to minus 2. So my answer is x is equal to a negative 2 plus or minus the square root of 13. So then what comes out of this? X equals a negative 2 plus the square root of 13. So I have the positive route. And I also have the negative route, negative 2 minus the square root of 13. And so I can go the positive side with an addition or the negative side with a subtraction in there. So you can go 2 different ways with that one. Here's another one. How about parenthesis 4x plus 8 squared equals 80. What happens to that thing? So, same basic idea. Take the square root of one side. Take the square root of the other side. So the left is pretty easy. Leaves me with 4x plus 8. What does the other side leave me with? Well, now we're back to chapter 9. Remember, chapter 9 was going to come back in here. What can I do with 80? Well, 80 can break down to 8 times 10. 8 breaks down to 2 times 4. 4 breaks down to 2 times 2. 10 breaks down to 2 times 5. So I got 1, 2, 3, 4 2's times a 5. And I want the square root of that. So really, I have 4x plus 8 is equal to plus or minus, pull out 2 2's or pull out a 4, the square root of 5. You okay with that part? Okay, no different than what we did back in good old chapter 9, because it's the exact same process in there. Yep, you gotta finish it. So move 8 over. So 4x equals a negative 8 plus or minus 4, the square root of 5. Divide everybody by 4. And then what do you notice? Good old chapter 9 back again. What's wrong with that? Jenna, what's wrong with that? Can reduce it. Yeah, I can do my triples in here. My triple reducing stuff in there. So I can pull a 4 out of here, 4 out of here, and a 4 out of there. So really I have x is equal to a negative 2 plus or minus. This 4 is gone. And the bottom 4 is all gone. So that's my answer. In Hawks, though, remember they want it written as x equals a negative 2 plus the square root of 5, and x equals a negative 2 minus the square root of 5. And you'll leave it that way. All right? What do you think? Okay, let's see if I can find you another one. This one kind of throws it all in together. 2 parenthesis y plus 2 equals 160. So this is squared. I guess I should put my square in there. So first, divide by 2. 2 goes into 60, 80. Kind of nice to getting to throwing these 80s in there all the time. Square root both sides. So I have y plus 2 equals plus or minus the square root of 80. We just did 80, so we knew we could pull out a 4 and leave a 5 underneath. And then last of all, subtract 2, and you find y is equal to a negative 2 plus or minus 4, the square root of 5. Okay? So that's what you'd end up doing with that one. And to come up with your answers and your solutions to it. Okay? See if I got another one in here that gets kind of complicated. I thought they had some negative ones in there, and of course when I want to find one that's got a... Oh, how about this one? Here, we'll get this out of the way. 8, or x plus 8 equals, and that's squared on this side, equals 16. So, take square root of both sides. Square root of 16 is a plus or minus 4. Square root of this side leaves me with x plus 8 minus 8. When you get straight numbers, you still have 2 answers to this one. And your 2 answers end up being a negative 8 plus 4 and a negative 8 minus 4. And so my one answer is negative 8 plus 4, or negative 4. The other answer is a negative 8, and a negative 4 is a negative 12. So you get some combinations of stuff in there with that. And so that's what happens to those. See what you get on this one. 8 y plus 1 squared is equal to 75. So work that one out. See what happens to it. So if you took square roots of both sides, Square root of that side removes the squared symbol. This side, 75 is made up of 25 times 3. So 25 is perfect square, so I can pull out a 5. Leaving a 3. Move my negative 1 over. Dividing by 8. I find out that, whoops, I left off my 8 under here. Go back and looking at it, and I left off an 8. So my 8 needs to be part of that answer because there's any cancellations that happen within that one. So you got to put your 8 underneath there, and you end up with this for your answer. Now when you type this into Hawks, put your fraction in first, okay? Then go to the top numerator part, then type this piece in, and then go to the bottom and put your 8. That, I think, when I was going through and doing this, I was like, oh God, I forgot that fraction, okay? So don't forget to put your fraction in first because of getting that 8 on the bottom. Because I typed all this top part in, and then I think, oh shoot, I left off the 8, so you have to start all over again. So I kind of feel your frustrations with that sometimes of what happens with your Hawk stuff, but that's what you gotta do to those, okay? Any questions with that stuff? Okay, all right, so I think we are